Hello everyone. This is the second video of this series on modular coordination, which means you have understood the basics of modular coordination. That's great. So you have understood the following things so far. 1. What are basic module, M? 2. What are multi-modules? 3. What are submodules? Now here, we will learn the various terms used while working in modular co-coordination. This is important, because, without understanding the language of modular coordination, you will find it difficult to coordinate your designs at a global level. So in this video we see all those terms. What is modular reference system? Modular points, modular lines, and modular planes, zones, controlling planes, coordinating planes, etc. Handing it over to the tutor.
Hi everyone. Let's start. The first lesson is on the building component and its sizes. These are the basic terms. First, modular component. This is a building product formed as a distinct unit. Example: tiles, glass panel, etc. A component whose coordinating sizes are modular. Second, modular element. This is a part of a building or structure having its own functional identity, such as a footing, a floor, a roof, a wall, or a column. An element whose coordinating sizes are modular. Third, work size, manufacturing dimension, a dimension used by the manufacturer of a building component or assembly to ensure that the actual dimension lies between the maximum dimension and the minimum dimension. Second lesson, the building reference system. As architects and engineers, we have been using reference systems right from day one. It's a system of points, lines, and planes, on which the sizes and positions of a building component are placed, so like when we draw plans, elevations, sections, on the x-axis, y-axis, or z-axis. These are also called reference plane, so we have a xy plane or a xz plane or a yz plane. So similarly, when using modular coordination, a modular line is a line of a modular reference system. A modular plane is a plane of a modular reference system. A modular zone is a zone between modular planes. Okay. Next, modular grid. This is a planning grid for making the plan of a building, where the distance between consecutive parallel lines is the basic module or a multiple thereof. A modular space grid is three-dimensional, XYZ axis. Third lesson, zones. A zone, it is a space between reference planes, within which a building component is arranged. The space may at times be left unfilled also. The wall zone, this is a zone where the wall is accommodated and it includes the wall finishes. The floor zone, this is the space in the section of buildings where the floor assembly is accommodated. It extends from the top of the floor finish to the bottom of the ceiling of the floor below. The roof zone, this is the zone stretching from the bottom of the ceiling of the last floor to the top of the roof of the building. I hope you have understood so far. You can rewind a little and take some notes also. Okay, let's move on. Fourth lesson, the controlling reference system. That is, the controlling plane which give the reference to where the structural elements like the columns, beams, slabs, etc. have to be placed. Floor-to-floor height, this is the dimension between the upper controlling plane of one floor zone and the upper controlling plane of the floor zone immediately above. Floor-to-ceiling height, this is the dimension between the upper controlling plane of one floor zone and the lower controlling plane of the floor or roof zone immediately above. Floor-to-roof height, this is the height between the upper controlling plane of one floor and the upper controlling plane of the roof immediately above. Fifth lesson, the component reference system. Components means parts, elements of the structure. Coordinating line, the line bounding the zones where elements or components are fitted. This is important while assembling all parts of structure together. Coordinating space is a space bounded by coordinating planes, allocated to a building component or assembly, including allowance for joints and tolerances. Coordinating dimension. This is a dimension of a coordinating space. It can also be a dimension which is common to two or more building components to permit their assembly. Work size, the size of a coordinating dimension. Okay. I have taught you only the terms that are absolutely necessary for you to understand modular coordination. Please watch again and take notes. You will need them while making your drawings. If you want to know all the other terms under modular coordination systems, you can study the manual attached in the description box. But before moving on, don't forget to like, share, and subscribe to the channel. Please forward the links to all your friends who are studying architecture or engineering. It will definitely help them understand this topic better. Okay. Next, please go to video 03 to understand grids in modular coordination.